Okay, guys, week 8. Wow, that went really quickly. Not so happy that it went really quickly. I'm having a lot of fun doing this. Okay, so Cyrus, you did the homework. Else you haven't turned it in yet. So that the pieces that you didn't get to in last session, we will talk about in this session. Had no idea how to do what we were doing because the truth is I'm trying to space things out so I don't cover too little, but I don't spend 3 hours, which I would gladly do, going over too much stuff. Okay, so So when last we left off, we were looking at cron utility that allows you to set tasks to be performed at specific intervals, and you guys did really well with the in-class work. Okay, going to move the stuff. Oh, bummer. Okay, I should make that smaller. We're going to move into more stuff that we were going to cover this week. Okay. Before I keep going, I have a fan on because it's like 930 degrees here in Israel. Is the fan bothering you? Is it too much background noise? Because the choice, fine. If it's not bothering you, great, because you'd think that it would be raining, I'd just be sweating all. Okay. Okay, so you're familiar with the idea of zip files, I'm sure, from using your computers, is that it's a way to send a single file encoded in a way that when you, it's a single file that's made up of one or more files or folders that you can send to people, download and whatnot, in order to package everything together. So Linux has the same thing. So these zip files, the zip compression algorithm, the math that is used to create a zip file, to turn bytes into a single file that can be compressed, is proprietary, meaning that somebody owns the rights to the algorithm. Now, they're kind of there have been tools that use the zip algorithm. There are tools that have rewritten the zip algorithm and released them for free. Windows, very early on, worked out with the people that owned the algorithm for zip compression, and they got paid a lot of money. And there was a utility called WinZip that was very popular, and it was shareware, and you paid for it, whatever. Okay. If you remember back to the very first lesson, Linux users are inherently against proprietary or closed source utilities and information. Information wants to be free. So there are different. Zip is one way of doing it. There are other ways that predated Windows and then came after Windows that improved on the zip compression algorithm. There were, it was good, but there was room for improvement, and the math nerds that took care of it made it better. Okay. All right. So the archive that predates, or the archiving utility that predates zip files, is called tar, and tar stands for Tape Archive. It was originally a program that once you were finished with your project or whatever, you wouldn't say disk space was crazy expensive. I still remember when I worked in information services back in the mid 80s. So there were a bank of machines, about 6 of them, and they're about as big as your mom's washing machine. Okay, she got the big front load, top load washing machine. Okay, these were disk drives. I kid you not, they were disk drives. And think about USB. Yeah, I haven't gotten to the good part yet. Think about USB drives, like the little USB drive. I have them lying around here. I got a little USB drive, 32 gigs. I actually just ordered one, 2 terabyte USB drive. I'm going to take it and put it in my media. I'm not even going to bother installing. It's like not even a thing into a USB slot, and I'll be able to store another 2 terabytes of movies and files and stuff like that. Okay, so these washing machine sized disk drives. Hell, let me type this out. 320 megabytes. Now you can say, wow. Disk drives were, and this is an IBM thing, and they were, okay, right. No, megabytes. A lot. Okay, let's go, yeah, again. So let's go against 1,000 bytes, right? Or 1024, technically. Okay, 1 megabyte is 1024 kilobytes. Okay, 1 gigabyte is 1024 megabytes. Okay, so there were 320 each. I mean, crazy. Okay, it doesn't matter. So that was very expensive. Tape media, like cassettes. I don't know if your parents still have cassettes hanging around the house somewhere, maybe. Want to get on the same page, gentlemen? Okay, so think of cassette tapes. So these tapes were about as big as a dinner plate, and it had, who knows, a couple of 1,000 feet of tape space. So when you wanted to finish, you wanted to write to it, you would write the file to the tape archive, and it would send it to, and it would record your work on the tape archive, and then you could take your tape with you to another university and put it on, and okay, fine. That's where the name TAR comes from, tape archive. Now we don't need that anymore, because now disk space is a commodity, and we have tons of gigabytes all over in cloud and whatever. But the compression scheme is still relevant for us, because we can use it to take a folder, and we can, instead of sending individual files in the folder, a folder is like a construct. It's not an actual folder. It's bits and bytes, but it's the way that Linux thinks about things is that files are associated with folders. And okay, so you want to take all that, you want to put it into one file, and now if it's a video file or a bunch of image files, stuff, or text files, whatever, might be a couple hundred megabytes, which is kind of big. You can't really email something that's a couple hundred megabytes. So you can compress it, and then using the tar utility, you can actually tell it how to compress it, which compression scheme you want to use. Now, you can not use a compression scheme. That's perfectly valid, but as long as it's available, hey, what the heck? Or you can use the different compression schemes that you can see. Is that there's one called bzip. There's one. Let me turn my manual pointer. There's one called bzip. There's one called xz. That's actually a newer one. There's gzip, and gzip it's the zip compression, only it's open source, which is what we like. So G stands for GNU, which is GNU, which is, we covered that. Actually, did I ever tell you what GNU stands for? I know, let me flip back to like, didn't work. 2, 3. Okay, so GPL stands for the new public license. GNU public license, and there are a couple of different versions of it that cover it's a legal document that allows the freedom to distribute, redistribute, to improve, to hack into it and improve security, fix bugs, and so on and so forth. I use hack in the good way. It means a hacker, when I typically refer to, is somebody who uses their curiosity to learn stuff about technology. That to me is the real definition of a hacker. I might even put that on the final, so write that down. But when I'm teaching the ethical hacking course, I mean it in the media way of a miscreant that is looking to break into and violate computer systems. Anyway, so GNU stands for News, Not Unix. So this is a joke because Richard Stallman is hysterically funny, and it is a recursive acronym because GNU never stands for anything. GNU stands for News, Not Unix. Now, you might be asking, what is an ox doing in the logo? Well, it's not an ox, it's a GNU. And it's a GNU is a kind of like it's kind of like a cow or buffalo. It's a GNU. Okay, fine, there you go. Okay, so yes, News, Not Unix is what GNU stands for. And it's to differentiate between the Linux version that Linus Torvalds created and Richard Stallman and Linus kind of got together and sorted their stuff out, got it together. Okay, so that's what the G stands for in gzip and gunzip. It stands for GNU. Alrighty. So in order to, let me flip around. I've actually found something I wanted to. I don't want that. 2 seconds. Okay. I'm just going to actually have. Bummer. I can't. All right. I'll put it in. All right. I'm not re-uploading this. That was just cuckoo. It took so long to upload this thing. So, all right, let me see if I can. Okay, just doing some stuff on the side here. Just give me. Okay, come on. Okay, all right. Alrighty. Alright, you can't see what I'm looking at, but that's okay because I'm about to cut and paste it into the whiteboard. Thank you for your forbearance and patience. Prince among men. Come on. There we go. Okay, so the tar archive, these are all the different ways that... drag this? Yes, I can. Hooray. There you go. Okay, so this is the several ways that we use tar in order to compress or extract or decompress our files. Okay, so the first one, you would issue the command tar, and then you would give it. Now, I'm old, so I would actually put a tick mark, but you don't have to. But it asks for the what you want to do. Do you want to see or exit? You can either compress it or you can extract it. So you have to have either a C or an X, otherwise this is not going to know what to do. It's like you're not giving me enough instructions. Okay? F means this is the file, and important is that when you chain these parameters together, Okay, the F has to come last. All right, because you are okay, sorry, got a little distracted there. Because the F refers to the file that we're talking about. So you can actually add another flag of V, and V means turn on verbose. But you would have to do CVF. You can't do CFV. So the F is the last in the chain of what you want to do, and then you have the name of the archive that you want to create, and then you would refer to either the directory or the file. That's actually incomplete, funnily enough. The directory or the file that you want to turn into a you want to turn into a ball. Let me type that out. Okay, that's what we call it. We call it a tar ball. Now you're cool. What can I say? Tar, create. Okay that you're cool, or okay that's what we call it? Or okay that I'm old? Okay, so we have the command, the tar command, and then want to issue the C or create, and then the V command of verbose will give you an output on the screen what it is that's happening. F being the file that we're going to create, and we're calling it archive.tar, and then a space, and then the actual directory that we want to create a tarball out of. Okay, so if you're in your home directory, do the command tar cvf space pictures.tar, why not? Pictures.tar space, and then pictures. Okay, so let me create with verbosity pictures.tar pictures, and what is that? You know, if you have a lot of pictures in your pictures directory, terrific. It'll just go through inflating, and it'll run through it, and then if you do an LL, you'll in your home directory that there is now a file called pictures.tar, and you'll notice that the file size is hold on a second. Okay, good. That the file size it's the collected file size of the entire pictures folder. Y'all with me? Okay. And of course, if you have no pictures in the pictures folder, then surprise it for the second, and you're not going to have anything there. Okay. It'll still have a file size because it'll have cowardly refusing. That's unfortunate. Hold on a second. No, D tar cvf pictures tar. No, it worked for me. Ah, okay, right. So my picture, you'll see that on my drop down that it went through, like you saw the last bit of it. Okay, fine. So okay, I'm trying to think of what directory. You don't really have a directory, and I don't want you to do your actual home directory. It's annoying. Okay, fine. Whatever. Not going to worry about it at the moment. Okay. No, I have to worry about it. I have to. All right. Do you have anything in your documents, your downloads folders? Oh, I hate that. Okay. So then do the same thing, but instead of pictures, do downloads or documents. Okay. And you'll see it'll deflate, or it actually didn't say deflate, but it just went through and told me everything that it's doing. Okay. So meaning you don't have any you don't have any files in your okay, and your issue. Okay. Okay. And you're in your home directory, right? And you type in tar cvf dls.tar/downloads. Okay, and it says it's an empty archive. Meaning that it can't do it. It can do it, but it's humor. Oh wait, there shouldn't be a period here. If I see tar cf downloads.tar space downloads. Right, you capitalization and everything. Cyrus, what about you? Okay. Okay. Awesome. Okay, so now what I want you to do is I want you to move that directory. So move whatever the name is, file parts, to temp. Okay, and when you change to temp and list it, you should see that downloads.tar file. Okay. No, so there's no temp directory, and that can't be right. No, that's okay. No, whatever you called it, if you called it downloads.tar or dl.tar or whatever it is, that was just, that's why I put it in quotes, just to, I don't know what you called it. Okay. Okay. CD, make sure that you're in your home directory. Okay, ls, and what is the name of the tar file that That's sad. Okay, so recreate it. tar cvf downloads tar. Cyrus, you playing along? We said that we had a file in there. Okay, tar cf words.txt. What happens if you do that? What happened to words.txt we were working at? We're going to need that file. Okay. Okay, this is what I'm going to do. I'm going to leave this here. I'm going to it's a fairly straightforward. I'm going to teach it as if and let's just use our imaginations. XF would open up that tar file. Okay, so if you're next to your brother, if you just peek in, that's weird. So C and X, again, C and X are opposites. C will extract the file. Okay, if you extract the file to if you did this and you extract it to the same place, it's gonna yell at you, overwrite what. So when I'm extracting stuff, I'm getting an idea. Hold on a second. Getting an idea. No, that's not what I want. Alright. Okay. Alright. If we include compression scheme, if we identify a compression scheme that we will compress it using that compression scheme, we have a file that has identified its compression scheme with an extension, then we would use the compression scheme flag to specify the extraction of that using that compression scheme. So in the next two examples that are on the whiteboard, tar czf archive tar.gz, we're creating it is we have to say, well, we're using algorithm, so and that's identified in the flag cluster. Okay, so we're creating a gzipped file called archive.tar.gz. It's a convention. You do need the GZ part because you kind of have to let other people know what compression scheme you're using. The tar part, you don't need it so much, but it will help people it'll help you see that it's a tarball that's been gzipped, so you'll know how to extract it from the command line. Okay? The opposite, xzf, you don't have to give it the directory that you're extracting it to. It will automatically extract it into the directory, and if the person that created the compressed file did it the right way, it'll go into its own folder. Okay, the lowercase j is the same thing. Instead of using gzip or instead of using newzip for the compression algorithm, it uses bzip, and it's actually bz2 because probably because it's the second version of it. Honestly, I forgot to look it up. So XJF would then extract a bzip file from, into it would expand it or explode it into the current directory. A capital J, and let me go back to here. You can see a capital J will use this XZ compression, which is relatively new compression. It's a little bit tighter. All the cool kids are doing it. So it would be C capital JF or X capital JF to use the XZ compression. Okay, there is a gzip and gunzip in your computers. If you do a man search for gzip, you should come up with a man file that will that it's the same compression scheme as using the lowercase z, but it's a separate utility. So if it's not a tarball, that would be the case. If it doesn't indicate that it's a tarball file with .tar.gz, then it's just a gzip file. You wouldn't necessarily use tar to extract it. You might have to use gzip or gunzip in order to extract it. Okay? I will take questions at the end of the class. Okay. Alright, cron, that was a big headspace. Tar, that was a big headspace. Let's have a little bit more fun. Okay? Issue the command df, and it will tell you what your disk space usage is. And it will go by each of the how do I explain it? Each of the points at which you have a disk or a pseudo disk or a type folder to that's been mounted, that's connected to the file system. Now we're not really going to go into mounting and unmounting. That's really would be the next level class. I'm not old as yet, or even John, I haven't talked to them about an intermediate class, but that's when you really roll your hand, roll your sleeves up and get one. At least that's the plan. Anyway, so if you do a df and then paste it into the chat, let's take a look at what we've got. Okay, I happen to have a fairly complicated one. I don't even know why I have a complicated. Why do I have such a complicated one? Whatever. I have a complicated one and I don't really need it. I don't want to show it to you because it's stupid. So let me see if I can find a better one. Gee, Siemens. Okay. So yeah, this one's a little bit simpler. This is a server that I maintain. Okay. I want to create a new one. Okay. Yeah, that's great. Not quite what I meant. No, only because it came out spazzy. It's all shut together. So I did not plan on. Oh, it's all monospace too. So okay, all right. So this is a server that I'm. Brother, this is a server that I'm responsible for. Okay, and. Okay, and it's telling me, okay, okay, let's get to the important part. Okay, we can see that I have this one line. That's dev stands for devices.
and VDA is a virtual disk A. Okay, because it's a cloud server, so it doesn't have actual disk space. It's mounted as a virtual disk. And we can see, skipping the used and available, we see the percentage of it. It says it's 42% used, so I'm a little under halfway used up, so maybe I should clear some stuff out. And then, where is it connected to the file system? Well, it's actually connected at the root. That's at the main. So in that slash directory, you have everything that's underneath it that we looked at, the temp and root and bin and home and so on and so forth. Okay. So temporary files, different types of file systems, we're not going to deal with. Actually, let me think. Maybe I could find a different one.
Another one. Better idea. Be a better idea if I hit the actual key that I needed. Okay, and I'm going to copy this, and if I can paste this here. Come on, what do we think? Yes, no? There's PDF. Guess what? Guess what? Are you kidding me? Oh my god. Okay. Give me 4 seconds. Let me. This is not. Oh, okay. Create a new asset. Save it as. This is going to be annoying. Jigsaw value bug. Oh, that's cute. Okay, and I go here and browsing file. Go to. Yes, I'm talking to myself. It's frustrating. Are you sure you have one space in between the command and the flags and the file name? If it has to be only one space, it can't be a tab, it can't be even 2 spaces. Just double check that. Oh, well then there's that. Okay. Okay. I'm going to open this up so that we can see everything. Shut this. How do I shut this? Go away. Okay, so what you're looking at is actually 2 side-by-side terminals. Okay. So now I'm going to remember I was talking about the USB drive that I was connected to. Oh, and it's not even a great one because it wraps, because I'm really firing on all cylinders today. Okay. Okay. This file system, this is the server that I have in my house that holds all of my stuff. Okay. And I have this disk drive, this SDB. Do I have I don't have a pointer. I don't have a pointer. Okay. You see, it says dev SDB. Dev SDB1. Okay, that means that's referring to the physical device that's connected to my machine,
You can see that it's 96% full. And what's the mount point? Where is it connected to my file system? It's connected to the file system in the media in the media folder, and then this huge serial number looking thing. It's an automatic folder that mounts. Okay, and then there are other folders that are mounted. So one's mounted as export movies, export Marc, music, incoming, distros, and Miriam is my wife's name. Those are all different points at which this server can be connected to. So if you were to look at it in a network browser on a Mac or in Windows, they would look like different folders. They are different folders, but they've been specifically exposed to be able to be connected to, so we can watch movies and TV shows and whatnot. Okay, and then I have that Marc as my backup, and music is where I store my MP3s and so on and so forth. We have another one on the right hand side. That was the virtual one that we were looking at, so that's 42% full. You can see that this one's 96% full. And what's interesting, if you look here, this dev disk, so I have the root mount point, the entire operating system. I'm only using 2% of a rather large disk drive. So I'm using, it's this, it's a 500 megabyte disk drive. It must be something like a 500 megabyte disk drive. And I'm only using a little bit. I'm using like maybe 8-10 megabytes for the file system itself. So I actually have all this extra disk space. So the second disk that I've mounted, which is another 500 gigs, I'm not really utilizing it properly. So what I would do is I would move stuff around and remount it so that I could start using up that second disk drive, this dev disk, as opposed to dev SDB one. Okay, all right. Now that we've gone completely off the rails here, let's close this and okay. All right, so that gives you a percentage of the disk space usage. Now there's an interesting flag, the tick H flag. DFH will give you, instead of giving you bytes, those long, big, ridiculous numbers that nobody wants to count, this 138, all that, tick H will give you human readable format. So it'll break it down for you into gigabytes or terabytes or megabytes or whatever it is. Okay, so DF tick H will flag it as for human reading. Okay, DU is sort of similar. DU will go through and, well, how do I explain DU? It gives you, you know what, do that. Do DU tick H for human purposes, okay? And what you'll see is that it'll actually run down and it'll give you a listing of how much each directory is using. Okay, so if you do a, what did I just say? If you do a DU tick H, you'll see that it'll run through and it'll count from this directory and sub everything else. It'll tell you exactly how much everything, what space is taking up. So DU tick H, now DU tick okay, so DU tick SH will give you a summary or total. Okay, and there's man-time stuff. There's manual page stuff for all the rest of it. Okay, so DU H pictures. Okay, so if I issue the command on my command line, disk usage, summary, human format, pictures. and it gives me the response that pictures is occupying 194 megabytes. It looks like this: 194 M. Oh, for God's sakes. Pictures. Okay, it issues a response like that. So it tells me. So if you're looking to see if you need to clean stuff out or whatever, you use this. This is more for maintenance and administration. It's a good thing to know. Okay, so that the file system tells you how much space is left. The percentage column is usually what you're looking for when you do a DF. So it tells you how much space you have left. So I know that on my media server, I'm running out of space. I gotta flip things around. Of course, I solved it the easy way, and I just bought another 2 terabytes. I'm gonna shove that in, and I'll be good to go for another couple of years. Okay, DU will give you specifics. It'll give you a summary or give you specifics on folders, and it'll drill down into your file system to give you everything you want. Or you can specify a specific folder, and it will and it'll show you that information. Okay, so uptime. Uptime is a simple one. Cyrus, you did the homework. I can't remember. Cyrus, you did the homework, right? You saw uptime. If you issue the command uptime, it'll tell you. Okay, so uptime will tell you what time it is, how long it's been up, by days and hours. It'll tell you how many users are connected to the system. Now, users in Linux think is how many terminals you have, each terminal is a new connection to the operating system, so how many terminals you have open. So what does that mean? That means that, when I issue, so I issued these 2 commands on my home computer, okay, and they look like, comes out looking like this. Okay. Come on. Okay, so I issue the command uptime, and it says it's 6:55 where I am. It's been my computer's been on consistently for 8 days, 10 hours, and 53 minutes. I have 7 users connected to my computer. Okay, and it says the load average is 577. Okay. That ain't great. That means that it's taking an average of 5 seconds to process any command that I'm issuing to it. Those numbers should usually be less than 1, because I have the browser and everything going on, so my computer's running what I would call a little bit slow. Okay? If it gets up to 29, that's bad, like bad. You can see, okay. So I said, 7 users. What do I have 7 users? What's going on there? And I said, okay. I have issued the command W. And the command W, you can see who is on, W stands for who. Who is connected to the system? Okay, fine. So now I'm looking and I see, fine. On the first one, I'm still, actually the first one's funny because that shouldn't even be open, but it's showing that I'm editing. VI is an editor. I'm editing that DigitalOcean, that script that I was talking about last week. Okay, the second, third, and fourth connections that I have are just waiting for commands. Nothing is in the middle of running. In the 5th slot, I actually have also mixer is a sound mixer. So it's actually I was playing with volume stuff on my computer. I was doing it from the command line, and so I have also mixer open. In the 6th slot, that's where I issued this who command, okay? And then the last one, I'm actually connected to SSH. I'm connected securely to, I don't even know where I'm securely connected to. I'm connected to that server that I was talking about that I'm connected to. I'm actually going to close that connection, and then if I issue the command again, it'll show that just by comparison is that now my actually I should issue it from here. That seventh terminal that we were looking at, I'm going to put it in the chat. Okay, that 7th terminal is now back to a bash prompt waiting for a command. Okay, so that's uptime, and for a special added bonus, who. Okay, great. Or sorry, W, not who. There's okay. Okay, uname. Let's issue the command uname. Let's see what happens. It'll tell you. Go ahead, type your response on what it says. Did I lose you? Okay. Okay, I issue from the command prompt, issue the command uname. Okay, so you're using your Mac, right? And Linux. Okay. Now issue the command uname A. That's the flag for all. Now it's a little bit different. Right? Okay, so gives you, yes, it gives you A for all. Right, exactly. Okay. And Ellisher says neon, blah, 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 right? Right, okay. Okay, so, okay. Okay, uname gives you, no problem. Uname gives you the information about the system. Okay? If you do a man, if you look at the man page for uname, you'll see exactly each piece that it is, that it's giving to you. You can extract individual pieces. Right now, so A is all, so it issues the name of the kernel, the network node host name, kernel release, whatever. Look at the man page for uname and get all the information that you need. Okay. Okay. I don't know. It's important when you're connected to other machines. You're not sure what you need to do. If you learn different flavors of Linux, you issue a uname and then you kind of get yourself oriented. Okay. The command file, if you issue file and then some sort of file, the operating system will make its best attempt to tell you what kind of file it is that you're asking for if it doesn't know. So if I issue a file, pictures.tar, it will tell me that pictures.tar is a tar archive. No surprise there. So I have this file. So if I issue file projects do cron resize py, it tells me. So if I issue on this Python script that I'm working on, if I issue this command, file projects do cron resize, so then it responds with the name of what we're talking about, and then it tells me what it is. So it tells me that it's a Python script, meaning a script for the Python language, and it's written in plain text or ASCII text, and it's a text executable versus a compiled executable. You know, if I were to do the same command against like the Chromium browser binary or something, it'll give me different information. Okay, I'm trying to see if file. Okay, you know, it'll give its best guess. If it's not sure, it'll default to its best guess, and you know that. So the file command is useful if you have a file that it has like some weird name. It might be helpful if you issue a file. Like sometimes I'll run a command and I'll do it wrong, and I'll wind up renaming something and can't figure out what it is that I did. So I'll do a file and it'll tell me what it's supposed to be, and then I can go back and correct my mistake. Okay, so that's the file command. The free command, you issue the free command, and it tells you how much memory space, how much memory you have. How much memory you have, how much memory the system has, how much is being used, how much is free, and so on and so forth. So when I issue the command, I actually see that I have the physical memory, the RAM that is installed in my laptop, and then I see that I also have swap space, which is a section of the disk drive that if the computer needs it, it can use it as memory storage. Okay, and that is the free command. You know, if you can't figure out why our computer's getting laggy and hosed and whatever, and you enter free or free tick H, which will give you human readable, you know, and you see that there's like 20 megabytes of memory left. Obviously, it will occur to you to start shutting things down. Okay. Okay, so those are 6 fun information statistics about the system. Okay. Now, system processes. So we're saying, well, what happens when your computer is, what happens if your computer's lag? What happens, why is my computer not working the way I want it to be working? Okay. So we have to investigate it. Linux is a terrific operating system, but it's not without its problems because it is only written by humans. So we want to see what's going on. We type in PSAUX. So that says, give me all the information about all the processes that are running right now on my machine. So I want you to do that. And you're going to see that it actually updates in, no, sorry, that's the next one. So if you do PSAUX, you can see all the different processes that are running. So I have like a bazillion processes that are running. Some are kernel processes. I'm pretty sure those are the ones in the brackets. And then I have all the other processes that are running. I have no idea why some of the things, I'm looking at it now, I'm like, what is going on? So you see that under the hood, your computer, everything is happening. Your network connection. I have Firefox running. I actually have Chromium running in the background, which isn't great either. I have Dropbox running. I have a little Docker, the same like you guys on Mac have at the bottom. I have Docker. I see that that I'm still editing my file somewhere. I have no idea where. I'll figure it out. Background processes like a program that's called K-Snapshot. So that's my screen grabber. So I'll show it to you. Like, you'll see it if you want to watch the video. But if I hit my print screen, what will happen is that it will actually copy what? If you type PSAUX, okay, anyway, so K-Snapshot, if I hit print screen on my keyboard, it copies the screen to the, okay, great. It copies the screen to an image snapshot, which I can save, and then there are other things that I can do for snapshotting. So you can see that on the video if you rewatch it. Okay, so that gives you, now it's great, but it's silly because there are hundreds of processes. What happened? Why is this useful? Well, what we're going to learn next class is that we'll actually use the grep command, which searches for strings in, we looked at files, but we're also going to learn how to use it to search for stuff that's coming from the screen itself, or coming from what's called standard output. So if you're looking for a process that's creating trouble on your computer, you will kind of narrow it down using a combination of process show, or PS, and grep. Okay, let's try top. Okay, I don't know if you have top on the Mac, but if you type in top, what you'll see is a real-time indicator of what your computer is in the middle of doing. Okay, so if you just type top, okay, great. So if you just type top, you'll see there's like all that information from uptime and free kind of gets stuck up in the top, and then you'll see that there are different. There's the process ID number, the user that initiated the process, the PR column stands for priority. NI stands for nice. The higher the number, the more it will allow other processes to go first. The lower the number and into the negatives is the more pushy it is. Virtual memory resources, CPU percentage is kind of the big one. So what I'm looking at now, and you can see this on the video when I post it, is that the screen capture, the program that I'm actually using to capture the video is taking up 133% of my CPU. So it's working pretty hard. After that is the classroom itself. So that's taking up another 95%. The good news is that I have 4 CPUs, so everything is still working. Obviously, if 212% of my computer was being used, it would be a problem. But that's also, explains why the load average is up near 7. Okay. Xorg for me is what's drawing everything on the screen. And shows Chromium browser, which is actually, these are things that are kind of running in the background. They should be closed, but they didn't die when I closed Chromium. So what I'll do is, if they're taking up memory, I will go and I'll kill them, and I'll get to killing in a minute. Okay, so that's top. If you hit the letter C, it will then expand the command, and it will show you exactly where the command, like what the command is that's running. So C toggles the full version of the command versus the abbreviated version of the command. Okay. HTOP you probably don't have installed, and I don't know, Cyrus, if you're going to be able to get HTOP, but Ellis, if you don't, you'll be able to do sudo apt-get install HTOP. Okay, and HTOP is it's multicolored top, and it's a little easier to use, and it actually shows it shows the usage of my processors. They're all maxing out because I have a lot of bad. Okay, so run HTOP, and you see HTOP. It colorizes things, but it's top with a little bit of pizzazz. Right? That would be the word for it. Okay, tells you how many tasks are running: 191, 824 threads. 7 threads are actually running. That means that the rest of them are waiting for something to happen. My uptime. Okay, and then I have 4 processors, so it lists the usage of my processors, and then my memory, my swap space. So my computer's working hard. Okay, terrific, Cyrus. When you get the opportunity to install that on your virtual machine, it's a better tool than Top. Okay, awesome. Okay, so if you hit Q for quitting, or F10. Yep. Okay. If you hit Q or F10, that'll quit out of HTOP. Okay, and then type in netstat. Okay, and netstat will give you the network processes that are happening on your computer as we speak. So if you type in netstat, it'll show you all the different connections that your computer is making. So mine's actually, again, because I'm going slowly, mine's taking a while, but it shows that my computer is connecting to stuff all over the place, and okay, anything that's running anything that's running in my system that makes a connection to something else. So I was connected to another server, or my computer allows Windows computers to connect to it, and any type of connection will show up in netstat. And we'll get to it a little bit in the last class. In the 10th class, we'll talk a little bit. We'll talk a lot about networking, and we'll get into it. But so you have these 4 commands. You have the processes, which you can either issue PS, AUX, which is a one-off, and it just shows you a snapshot of what's running on your computer. Top shows it to you in real time. HTOP shows it to you in better real time. And netstat shows you network connections, or network and socket connections. Okay? Awesome. Let's take a look at the next one. Okay. So with all this discussion with processes, what happens if a process is giving us trouble? And it happens. Not perfect, and things go awry, and we need to stop a process. For instance, I said that Chromium browser, even though I closed Chromium, it still has some processes that are open. Okay? So what I would do is, I have a few different options. So first I would do kill. In order to issue a kill command, kills a process, but you have to issue it by the process ID number. So again, I do PSAUX. It tells me all the processes that are running, and I want to. I don't know what I want to do. Okay, I want to. I don't want to kill Firefox. That would be bad. I'm trying to find something that I need to kill without completely destroying my computer and shutting it off and everything like that. Not happy. Let's see. Okay, let's just take one of these Chromium browser ones and hope for the best. Okay, so Chromium browser has something left open. It didn't die when I closed Chromium. Okay, fine. So what I'm going to do is I'm going to issue kill 27555. That's the process ID that I get from issuing PSAUX. I look and I kill 27555 and it happily terminates the process. I know the language is a little harsh, but what can you do? It issues a command to that process to stop. Okay. If a process is stubborn, there are different ways that you can force it to close. If you use, there are different ways that Linux communicates how to terminate a process. Maybe it sends a termination signal, which is to end gracefully, or might send a kill command, which says interrupt the process, shut down the memory, tells the kernel, tells the Linux operating system, the kernel, just forget it, just drop it completely from usage. Okay, it might happen. So if a process is being stubborn and not closing, you would kill tick 9. You're sending it actually, you can see them if you go to htop, you open up htop and you hit F9, you can see the commands on the signals, the kill signals on the right hand side. So again, htop and F9 shows all the different signals. So there's hang up, interrupt, quit. Okay, so 9 is a hard kill. A 15 is an even harder terminate, and most every other thing isn't really going to work on particular processes. So if you wanted to kill a stubborn process, you kill number 9 and then the PID, or kill -15 PID. And if you are trying to kill a process as a user and root or somebody else has initiated it, then you're going to have to do sudo and then redo the last item in history, so that it will then reissue as a super user kill with whatever process ID number. So that's where you would use the double bang in order to redo a process using the super user privileges. With me? Neither of you, okay, because neither of you blinked off means that you didn't actually kill your computers, which is great. Okay, so let's say you don't really have the patience for this, and I'm not going through and listing every process number and terminating every. Oh, awesome. Yeah, don't kill a NIT. That'll or the virtual box. That'll. Okay, anyway. Okay, I don't have the patience for this. I just need to. I need to free up some memory. Chromium is being a pain, and I am done. So what I'm going to do is, instead of dealing with the process IDs, I'm issuing kill all Chromium browser. Okay? And now, if I go back and look at PSAUX, and I actually have to issue it a couple of times, just to make sure, until it reports back to me that there are no processes found called with the name Chromium browser. Excuse me. So I issue it a few times, and it wipes it out. Now, if I look at my load average, yeah, of course it's gone up, right? Why not? Why shouldn't it have gone up? Okay. If it was really, I got Firefox all over the place. So I'm using Firefox for the classroom. I use Chromium ordinarily. So Firefox is just starting to. The reason I stopped using Firefox because it was a memory hog, and unfortunately it's the only browser that's working with the Jigsaw. So fine, whatever. Yeah, so Firefox is taking over, but I did kill all my Chromium browser processes. Again, it's not the application itself stopped running, but it didn't clean up its garbage, which is a technical term, I promise you. It did not do its garbage cleanup, so I just took care of it for it. And if you remember back a couple of lessons ago, when we were talking about aliases, that's actually one of my aliases. Instead of typing kill Chromium browser, I have an alias that all I have to do is type in KACB, and it issues a command kill all Chromium browser. Surprise. Okay. Now, open up Xterm, another version, another Xterm. Okay, just on your command line, type in Xterm, and when you're watching the video, type it with an R. There you go. Type in Xterm. Now I have Xterm. I have a little terminal window right in smack dab in the center of my screen over, and I'm looking at this Xterm. You with me? You got me? It's kind of important. So because we could do the wrong thing and you could. Okay. Okay. Let's say something's gone horribly wrong, and you have to install what? Xterm? Oh, on a Mac. Whatever terminal, just open up a terminal instance, whatever terminal instance you need to use. Okay, it doesn't specifically have to be Xterm. Just open up a terminal. I assume Linux. You're using Macs, and that's wonderful. Not Linux. It's a flavor of BSD, but we don't have to deal with that at the moment. Apple made a very conscious decision to do that, and okay, I have no problem with BSD. BSD is kind of like Unix, except that it's not, and it does things totally differently. Except that it works pretty much the same. So BSD is not a flavor of Linux. It's actually a completely different type of operating system, but it works a whole lot like Linux. Okay, you have a terminal window open. Now we're pretending that everything is going very badly. We have only 5 minutes left. Okay, everything is going. If something's gone horribly wrong in this terminal, it's not working. Okay, fine. We gotta do something. Okay. What I want you to do now in your first terminal is I want you to type in xkill, Xkill. Okay. Take a look now at your cursor. Your cursor should have changed to a red skull and crossbones. Don't click. Don't click anything. You're just listening, okay? Because you'll click on the chat and you'll close out the... Don't disappear on me. You've got 2 minutes left. Okay? Your cursor... Okay. Your cursor is changed to a red skull and crossbones, and all you need to do is to move your mouse over the graphical program that is giving you heartburn. Click once on your mouse, and Xkill, standing for the X Windows Manager, the GUI manager, Xkill will identify the program that's running, and it will issue the kill command to that process ID. So I click it, and it is gone. Okay? If you have successfully only cleared the X terminal that was that we opened up specifically for this purpose, then you can go ahead and chat and type, and everything is fine. So kill issues by process ID, issues a kill command by process ID. Kill all issues by the name of the program, application, utility, or whatever. Glad to hear. And Xkill is a graphical interface that allows you to it allows you to remove it by graphical means. Okay, excellent. We are perfect. We are awesome. I wasn't sure which this slide was going to fall under, but it's going to fall under next week. A lot of work next week. Okay, there is homework. Okay, I took the homework pieces from 7 that Cyrus you couldn't do, else you didn't do. I took them, I put them in homework for 8, so do your homework for 7 and 8, and let me know if you run into any problems. If you have any questions, I'm available, email me and whatnot. If you need any I know we were running into some trouble with tar, see if you can get through the homework with it. If you can get through the homework, terrific. If not, let's talk about it next week. Maybe if we have to spend an extra 10 minutes in class, we can do that also. Okay? Any other questions? Server is redo. Which? Okay. Okay, do me a favor, send me a screenshot, because shouldn't be a problem. That part of it really shouldn't be a problem. But okay, so send me a screen. I gotta take care of something, so I can't quite. All right. Let's see. It says the server is redirecting too many times. From which URL is it redirecting too many times? That's just on me. And Ms. Gisler, can you explain to me what the difference was between what you posted and now why it works? Oh man, I gotta go. Alright. Okay. You also used HTTP instead of HTTPS. That's the reason. My server's protected that way. Gentlemen, have a terrific week, and I look forward to your homework, past, present, and future. Bye.